Okay, this is Chapter 4, Section 2. We're going to talk about how to multiply any two polynomials. We're going to use the FOIL method to multiply two binomials. We're going to use a rule to square a binomial and use a rule to multiply a sum and difference of the same two terms. And we're going to, for functions f described by second degree polynomials, we're going to find and simplify notation like f of a plus h and f of a plus h minus f of a. To multiply monomials, we first multiply their coefficients. Remember, the coefficient is the number in front of the variable. Then we're going to multiply the variables using the rules for exponents and the commutative and associative laws, which we'll talk about. So our very first example, they have taken and they're saying that they would like us to multiply 3x squared y to the 7th times 4x y to the 3rd. So if you'll look here, the first thing they did was they took the 3 and they multiplied it times the 4. So they've got 3 times 4. Then they took the x squared and multiplied it by x. So x squared times x, which those are both the same variable. And if there's no number here, remember that this is x to the first power. And then they've got y to the 7th times y to the 3rd at the end. So 3 times 4 was 12. When you multiply exponents, you add the exponent. So they have to have the same base. Both of these have a base of x. And then they did 2 plus 1. And then both of these have a base of y. So they said 7 plus 3. When you multiply exponents, you add them. So that's going to be 12, x to the 3rd, y to the 10th when they add the exponents there. The distributive law is the basis for multiplying polynomials other than monomials. So we've already used the distributive property sum in this class, but basically they're saying we're going to multiply 2a squared b to the 7th times 3ab minus 6a squared b to the 3rd. So you can see that they've drawn that they want to multiply this first, and then they want to multiply by this second. So the first time they said 2a squared b to the 7th times 3ab. The second time they've got 2, and they put a minus, right? Minus right here, because we're doing 2a squared b to the 7th times 6a squared b to the 3rd, which is what they have written right here. Okay, so to get the 6, they've done 2 times 3, which is 6. And then remember that we're going to add the exponents that have the same base. So I've got an a here and an a here. This a didn't have anything. It would be a to the 1st. So they did 2 plus 1 to get a to the 3rd. B to the 7th and b, remember there's nothing here, so this would be b to the 1st. So they did 7 plus 1 to get b to the 8th. Okay, now we're going to move over here. We bring down our negative. Then we would do 2 times 6, or you could just say negative 2 times 6, which would be negative 12. So either way you want to do that. And then we've got a and a, so we're going to add the exponents. 2 and 2 would get me a to the 4th. Then we're going to look at b and b. Those are both the same base, so we would add the exponents 7 and 3 and get b to the 10th. Repeated use of the distributive law enables us to multiply any two polynomials, regardless of how many terms are in each. So if we want to multiply 3x plus 2 times 7x squared minus 2x plus 1, okay, then what we need to do is take that 3x plus 2 and multiply it by 7x squared, then multiply it by negative 2x, then multiply it by positive 1. So that's what they've done. The first step has 3x plus 2 times 7x squared. The next term says minus 3x plus 2 times the 2x, and then plus 3x plus 2 times the 1. Okay, then this is kind of written backwards from what we would see, but they're taking this and multiplying it by both of the things on the inside of the parentheses. So that's why they have written 3x times 7x squared, and then they did 7x squared times 2. That's how they're coming up with this. Then we'll bring down our minus. We've got 2x times 3x, 2x times 2, which would be right here. Now, we want to pay careful attention to the fact that this minus had to get distributed to both of these things. That's why both of these are negative. Okay? Then on this one, this is a plus, so we've got 1 times 3x and 1 times 2, which is going to give us our 3x plus 2. Okay, now they've simplified these things. So 7 times 3 is 21. X to the first and x squared, 1 plus 2 would give you 3. 2 times 7 is 14, and then we've got x squared. Here we've got a negative 3 times 2, which is negative 6. X times x, you would add the exponents. So this would be x squared. And then we've got negative 2 times 2x, which is going to give me negative 4x. And then 3x plus 2, there was nothing to do there. So then they worked on combining like terms. So there's no other x to the third through here, so they just wrote that one down. They put the 14x squared and the negative 6x squared together because they both are x squared. So 14 minus 6 would give you 8x squared. These two can go together because they're both x raised to the first power. So negative 4x plus 3x would give you negative 1x. And traditionally we don't write the 1 in front of the x, we just assume that it's there. And then we've got our plus 2 that didn't have anything that would go with it. To multiply two polynomials p and q, select one of the polynomials, say p, then multiply each of the terms of p by each of the terms in q and collect the terms. Okay, so this is another example of how to do this type of problem. So they've written this in a different way. If you'll look, where they put the 5x to the third plus x squared plus 4x on the top, and then they put the x squared plus 3x on the bottom. Okay, so the first thing that they've done is they take and they multiply this 3x, taking this first term here, and they're multiplying this 3x times each one of these things. This is just another method that you could use. Okay, so it's a positive 3x, so they said 3 times 5 to get 15. This is x to the first times x to the third. And remember that you're going to add the 3 and the 1 to get x to the fourth. Then they take 3x and multiply it by x squared. So 3 times, this would be a 1. 3 times 1 is 3. X times x squared, well, this is x to the first, so you would add the 1 and the 2 and get x to the third. 3 times 4 would give you the 12. X to the first and x to the first. 1 plus 1 would give us x to the second. Okay, then they moved over to our other term, and our x squared here, and they took the x squared and multiplied it by each one of these things. So they start at this end, and it doesn't really matter if you scoot over here as long as you know that you're trying to line things up. So that's why there was no other x to the fifth, and when you do x squared and x to the third, you would get x to the fifth because 3 and 2 is 1. I mean, 3 and 2 is 5, so that's where this x to the fifth. 5 times 1 is where the 5 comes from. And since there was no x to the fifth in this top row, they just scooted over and added it to this end because it's bigger than x to the fourth. Then we would do x squared times x squared. Well, that's x to the fourth, and they lined it up underneath the other x to the fourth. And then lastly, you would need to do x squared times 4x, which would be 4x to the third. And they lined it up under the other x to the third. So 12x squared 3 and 4 got us positive 7x to the third. 15 and 1 got us 16x to the fourth. And then we've brought down our 5x to the fifth. So when you only have a binomial in each one, in other words, they only have two terms, we can use this FOIL method. And it's first, outer, inner, last. So let's talk about this. This is just a method for how to do these problems. So FOIL, first, means take the first two terms in each one of these little parentheses and multiply them. So x times x would give us x squared. So first, then outer. Okay, so the outer terms would be the ones on the outside of the two parentheses. So x times 6 would get me 6x. I stands for inner, and the inner terms would be the ones on the inside, these two. So negative 4 times x would get you negative 4x. And then last would be the negative 4 times the 6, because they're the last terms in the parentheses for each one. So negative 4 times 6 is negative 24. And then they just combined these two that are just x to the first power, because 6 minus 4 is 2, and they've simplified that a little bit. So first, outer, inner, last is just a tool that you can use to multiply these binomials. So they've done another one for us, and this only works if you've got if you've got two terms in each parentheses. So the first would be the 3x times the 5x. 3 times 5 gives you 15. X times x gets you x squared. Outer, okay, so the outer terms are going to be the ones on the outside. So they did 3 times 8 to get 24, and then they did x times y to get xy. Inner would be the ones on the inside. So y times 5x would get me 5xy. And then they did the last terms on the parentheses. So y times 8y would be 8y squared. We've got two like terms here. They both are xy's both raised to the first power, so those could go together. 24 and 5 would get you 29, and so this would be our final answer. The square of a binomial is the square of the first term plus or minus twice the product of the two terms plus the square of the second term. So this is just a trick that you can use. Man, to me, it is just easier to multiply it out than to try to remember this trick, but we can go over it. So they said if you're adding, okay, that you could follow this a plus b. So in our example, m is a and 7 is b. And so they're saying, well, just take a squared. So in our example, a is m, so m squared plus 2, and then multiply a times b together, which our a is m and our b is 7, so m times 7, and then b squared is 7 squared, because b is 7, and then simplify that, okay? You could also just think about the fact that this is just m plus, when we're squaring something, we're just saying m plus 7 times m plus 7. So you could use the first, outer, inner, last method. So first term, the outer term would be m times 7, which would be 7m. Inner terms, 7 times m. So I've done the first, the outer, the inner, and then the last terms would be 7 times 7, which is 49. And so my answer would be, when I combine the 7 m's here. Okay, so you could work it this way. One common mistake that people make on this type of problem is, and it's not equal to this, they want to say that they want to distribute this to both of these things. Say, well, it's m squared plus 49. That's not what m plus 7 squared means. You need to make sure that you write it m plus 7 times m plus 7. Do not do this. Not right. Okay. So here's another example that we have. They're saying take 2x minus 3xy squared times 2x minus 3xy squared. Okay, and I think that they have used the rule up here for subtraction. I'm going to scroll back up here. And they're saying since we're subtracting this, it's going to be a squared minus 2ab plus b squared. Okay, so they're just following this pattern. So A in this problem would be 2x, and B would be 3xy squared. That would be B, and A is 2x. So they're just plugging this stuff in. So if A is 2x, we would do 2x squared if we were doing that. Then we would write down minus 2. A is 2x, so they wrote 2x. B is 3xy squared, so they wrote that. And then they want to do b squared, and b is this, so they're squaring it. They've multiplied all this together. So 2x times 2x is 4x squared. Negative 2 times 2 is negative 4, times 3 is negative 12. And then we've got x to the first, both of these, so that would be x squared. And then a y squared, and then 3 times 3 is give you 9, x times x, x squared, y squared times y squared would be y to the 4th. Okay, but it's possible to just do the FOIL method instead of trying to remember all those formulas. Just know that if we're squaring this, we're multiplying these terms by themselves. Okay, and then you would do first, so 2x times 2x would be 4x squared. Outer, 2 times negative 3 would be negative 6. X times x would be x squared. Then we've got a y squared we need to add on. Inner would be these two, which would be negative 6. Negative 3 times 2 would be negative 6. X squared, y squared, and then the last terms, these two, negative 3 times negative 3 would be plus 9, and then x times x, x squared, y squared times y squared would be y to the 4th. And so if we combine like terms, I've got two terms with x squared, y squareds in them, so this negative 6 and another negative 6 would be negative 12. And so we could combine those, and we're getting the same answer as they got. Okay, so to me, I just don't have to memorize a formula whenever I do this. I can just use FOIL every single time. So the products of the sum and difference, if we do a plus b times a minus b, we've got another formula. It's just a squared minus b squared. So if one of them is addition and the other is subtraction, then they're saying, well, it's just, you just do y times y, which is y squared. You multiply the first terms and you multiply the last terms. Okay. But let's look at if we did FOIL with this. So if we had y plus 8 times y minus 8, we would multiply the first terms, which is y squared. The outer terms, y times negative 8 would be negative 8y. The inner terms would be 8y, and then the last terms would be negative 64. Well, if you'll look closely, negative 8y and positive 8y, they kind of cancel each other out, so we're just left with y squared minus 64, which is why this happens, and we only have to multiply the first and the last, the first two terms and the last two terms to get the answers to this problem. So once again, it doesn't matter how you do it, but if you use FOIL, you don't have to memorize all these other formulas. You would just know, I'm going to use FOIL. It might take a little bit of extra work, but it would stay with you. So here's one that they've done. They notice that this is a plus and this is a minus, so they just used their formula and multiplied 3 times 3, got 9. M times m and n times n ended up being m squared n squared. Then they did the last two terms. Well, a plus and a minus is going to get you a minus, and x squared times x squared would be x to the 4th. You could also use FOIL on that. Okay, so if I'm given f of x equals x squared plus 3x plus 2, and I want to find and simplify f of a plus h and f of a plus h minus f of a, how do we do that? Okay, I'm going to kind of make a side note over here. We talked about before how if our formula was f of x is equal to x squared plus 3x plus 2, which is what we have right here. If I said f of 2, well, what you're really doing is you're taking every time you see an x, I'm going to put a blank there, and you're plugging that 2 in those spots. So we would plug a 2 in there, and we would figure out, well, what is the answer to that? Okay, this is no different. They're saying, what is f of a plus h? So I'm going to scoot down here just so I have a little bit more room, but when we work this problem, if we have f of a plus h, and we're trying to figure out what x squared plus 3x plus 2 is, instead of the x's, so instead of x, I put a blank, then we've got squared, plus 3 times x, which is just going to be a blank, and then plus 2. So all I've done is rewrote this with the x's having blanks. Well, they're telling me, it's the same thing. They told you to plug in a 2 up here. They're telling you to plug in an a plus h. So all of these blanks would get an a plus h. Okay, now, we talked about the fact that a plus h squared means a plus h times a plus h. We could go ahead and distribute this. So that would get me 3a plus 3h. And then we've got plus 2. Now if we take care of this, a squared, so that's first, outer would be a times h, inner would also be a times h. Most of the time you write them in alphabetical order. If I did HA, it would be fine, but it would just not be what we're normally looking at. H times h would be h squared. So then we've got plus our 3a plus 3h plus 2. Okay, so I'm going to look through here and I'm going to see, do I have any other a squareds? No. Okay, I do have an h squared. That's the only one I see. I'm going to go ahead and take care of those two. I've got a combination of a plus h. I've got 2 of those. So I'm going to say plus 2ah. So I can put those together. I don't have any other a's, and I don't have any other h's, so this would be our final answer. We've combined like terms. The only 2 terms we could combine were these 2. We have 2 of those. Okay, so how do we do this problem where we're having to do f of a plus h minus f of a? Okay, well, I already know what f of a plus h is, right? We already did that. F of a plus h. So you might want to separate these things out. So we already calculated f of a plus h. It was a squared plus h squared plus 2ah plus 3a plus 3h plus 2. So, right, we already figured f of a plus h out, and it was this, and I just wrote it right here. They're wanting me to subtract, so they're wanting me to take that, and they're wanting me to subtract off f of a. So, I'm going to come under here and say minus f of a. Well, what are they? So, our original formula, remember that they're wanting us to plug things in. It's this x squared plus 3x plus 2. So instead of writing x squared plus 3x plus 2, I'm putting blanks in here. So blank squared plus 3 times blank plus 2. For the x's, I put blanks because they're wanting me to put an a in there. That's what the directions say. So when we reduce this, okay, I'm still subtracting something off, but the thing I'm subtracting off is a squared plus 3a plus 2. So if we start combining these, we would have a squared minus a squared. Those cancel out. We do have an h squared left. We have a 2ah left. The 3a minus 3a, those would cancel out. 3h doesn't have anything to go with it, so we still have that. 2 minus a negative 2 actually turns into 4. So I'm sorry, I wrote this down wrong. This is supposed to be a positive 2 right there because I just didn't carry it down correctly. So actually, we got 2 minus 2, which is nothing. So they've got the same thing we do, and that's how they came up with that. And that's the end of Chapter 4, Section 2.